Hi, we're going to keep going. So let's talk about lesson 22, which is hypothesis testing for proportions. So to be able to use hypothesis testing for proportions, it has to follow certain parameters. First is a simple random sample, then a population at least 20 times as large as the sample. And this is really important in statistics because you want a sample that will represent your population. And then the individuals in the population are divided into two categories. So you're not going to have more than two categories. It's basically going to be a yes/no question, or one group has to be one way and the other group has to be the other. So don't worry about having more than two categories. You won't see those kind of problems for lesson 22. And then the value of the sample size times the proportion, and the sample size times 1 minus the proportion are both at least 10. And we'll show how to solve those in just a minute. Okay. Again, there's three types of hypotheses. There's left-tailed, right-tailed, and two-tailed. Now, the thing about these is we're not using the mean symbol anymore. We're using the P symbol. And the thing that you'll look for with these kind of problems is you'll see the percentages in the thing. You won't see anything about average. You'll mainly see a percentage sign like 60%, 68%. You'll see those, and that's how you know that you're doing hypothesis testing for proportions. Okay, again, if it's a left-tailed test or less than, use the less than symbol on the alternative. If it's a right tail, it's a greater, and you use that in the alternative. And if it's a two-tailed, it means it's not equal to it. So, all right, so let's understand what the problem's looking for. It's looking for the population proportion, which is P with the subscriptive O, and it's specified by the null. X is the number of individuals in the sample who are in the specific category that you're doing the hypotheses on. N is the sample size, and of course, the level of significance or the level of confidence, okay? These are called one prop Z test, okay? So let's go look at it in the calculator. So if I go here, again, turn my calculator on, I'm going to go to stats, go over to test. For me, it's number 5 in my calculator, okay? And you can see there's no data that you can enter. This is all based on problems on statistics that you have. All right, so let's go down and let's do the example for this. Again, level of significance, level of confidence, just like lesson 20 and 21. So if you're not familiar with that, go back and look at it. And again, P is less than or equal to alpha, reject the null. And again, I use my silly rule of people eat fish from the River Nile. Okay, so let's look at this one. I'm trying to get the p-value. I'm going to write down my hypothesis so I conclude, and you can cross off the one that's not correct. That's the way I do it. I've always done it that way. So my example, a survey indicates that 50% of employees enjoy their jobs. A local company believes that more than 50% of its employees enjoy their jobs. The company surveyed 200 employees, and 120 reported they enjoy their jobs. Using the 0.0 level of significance, what do you conclude based on the p-value? Okay, it follows all the parameters above. We're going to just say that we're going to look and see that it does. Okay, so let's go here. The company believes it is higher than 50%, so it's a right-tailed test. So because a local company believes that more than 50% of the employees enjoy their job. So that's where I'm getting the greater than. So because I'm saying that 50 then, I'm going to go here and for my alternative do P is greater than 0.5. All I did was convert my percentage into a decimal. That's the only thing I did, and it's okay. You can do that, and especially for p-values, when we're doing this, we need to do that. So I need to understand what is in my problem. So my population proportion is 0.50, and I'm going to put this in the calculator as we go. 0.50, because that was what was in my hypotheses right up here. All right, so 120 people enjoyed their job. So that's one part of that's my first category I'm looking at. Remember, these have to be in two categories. So I'm saying my first category is people who enjoy their jobs, and the next category is people who don't enjoy their jobs. So for people who enjoy their jobs, it's 120. And then for my N, it's going to be 200. Okay? And again, I said this was a greater than, so I'm going all the way down to the last choice for my alternative hypothesis and hit enter. And then I go to calculate. Okay? And I get, again at the top, it's the one prop z-test. And again, I see my proportion is greater than 0.5, which again is my alternative. So if you look here and here, these are the same things. So if I keep scrolling down, let's talk about what I got. So I got my z-score is 2.82. My p is 0.0023. All right. My p-hat equals 0.6. My sample size is 200. All right, so let's go down and start looking at how I'm going to conclude this. So again, I compare my p-value to my level of significance. And if you see here, I just did that. So is 0.0023 less than or equal to 0.10? Yes, that's definitely less than that. If you get confused by these, add the same number of zeros behind. Like I could make the 0.1000, so I could compare 23 to 1,000, and I know 23 is a lot less than 1,000. So I can reject my null. So if I reject my null, that means my null is not true. If you look down here, it's not true, but that makes my alternative true. So because my alternative is true, I'm going to write my conclusion based on that. So I can conclude that there is enough evidence that the company is correct in its belief that the proportion of employees who enjoy their job is greater than 0.5 or 50%. Okay, that's all I did. I basically did almost the exact same stuff I did in lesson 20 and 21. Let me know if you have any questions, and I hope this helped.